In this video, we're computing the integral of sine 2x over 1 plus cosine 2x on the interval 0 to pi over 4. And I'm going to look at this thing with an informal chain rule backwards approach, because what I notice immediately is that the derivative of the denominator is basically sitting up there in the numerator. It just needs a minor adjustment to make that exact. So the derivative of the denominator is going to be a -2 times sine 2x. I'm just using the chain rule there to look at the derivative of that denominator. And just to verify this real quick, the derivative of the cosine function is the negative of the sine function. So I have the derivative of cosine 2x with respect to 2x, and that gives me negative sine 2x. And then the chain rule says, well, you have to tack on the derivative of the interior function, which was a 2. So to make the derivative of the denominator appear in the numerator, we need a factor of -2. Well, we can just multiply the interior by -2 if we want, as long as we compensate by multiplying by -1/2 out in front. And now I'm in this classic position where I recognize the derivative of the denominator sitting in the numerator. Well, this is exactly what natural log functions do. Just a quick reminder here. If I have a derivative of a natural log of some function, f of x, I start with the derivative of the natural log with respect to that interior function, which is 1 over f of x, then multiplied by the derivative of that interior function. This is the chain rule acting on this thing. So that produces an f prime of x over f of x, and that's exactly what we're looking at here. So this thing is going to integrate to -1/2 natural log absolute value of 1 plus cosine 2x. Now we just have to evaluate across the limits of integration. That was 0 to pi over 4. So I'll go ahead and factor the -1/2 out of it. And when we sub in the upper limit here, we're going to get natural log of 1 plus the cosine of pi over 2. But the cosine of pi over 2 is 0. So we end up with just the natural log of 1 for our upper limit. And then we subtract the natural log of 1 plus cosine 0. Well, cosine 0 is 1, so I end up with a natural log of 2 there. Now remember, the natural log of 1 is 0, so that term is gone. And then we'll distribute that -1/2 into this thing, and I end up with just a +1/2 natural log 2, and we're done. If you enjoyed this video, or at least found it useful, check out another one by clicking one of the links on the left, or click the Zach's Lab logo on the right to explore dozens of physics and math playlists. As always, you can leave your questions, comments, and requests in the comments section below, and I'll get back to you within 24 hours. Thanks for watching Zach's Lab, and best of luck on your math and physics journey.